Hello champion, I'm teacher Adam. Welcome to my math class. Today we're going to learn about expanding of algebra. So we are going to learn about expanding. What's meaning of expanding? That's the first thing. What is expanding? Expanding in math means, or in algebra, generally expanding means removing of brackets. So we do that, we expand by multiplying out. How do we multiply out? For example, you'll have a coefficient, let's say 3, and then you have inside A and B. So you multiply 3 by everything that is inside. 3 times A and 3 times B. You get 3A times 3A plus 3B. This is what you get. Or you can have 4 into bracket x plus y. Then you say 4 times x, you get 4x plus 4 times y, you get 4y. This is it. Or you can have 6 into, let's say, 2x plus 8y, and then you multiply, you say you get 12x plus 48y. This is called expanding, removing the bracket. Okay, and this is normally comes from smaller to big. So you are having algebraic expression, then you remove it from smaller to big. For example, let's say you have two algebraic expression. You have a plus b, and then 6, then plus 2 into a minus b. Then you're told to expand this and simplify. If you're told to expand and simplify, you have to remove the bracket first. Remove the bracket first by multiplying 6 times everything inside. 6 times a, 6a times b, 6b plus 2a minus 2b. Then what you do, you say 6a plus 2a plus 6b, collecting like terms, minus 2b. Then you have 8a plus 4b. That's it. So your answer becomes 8a plus 4b. Now, this is called expanding, removing the bracket. It means you are coming from smaller, you're coming from smaller to bigger numbers or expression. Okay, now what happens when you have, let's say you have 2 into let's say m plus n. You're told to expand this expression. So we have been told to expand these expressions. Be told to expand these expressions. So 2 into m plus n. So you multiply 2 by everything, you get 2m plus 2 times n, you get 2n. That's the answer. What about if you have 5 into 2 plus l? You say 5 times 2 is 10 plus 5 times l is 5l. That's the answer. What about you have 3 into 4 minus y? So 3 times 4, you get 12. 3 times y is 3y. That becomes the answer. Correct. What if you have given 4 into 5 plus 2 plus 2k? Multiply this. 4 times 5 is 20, and 4 times 2 is 8k. And you get your answer as that one. What if you are given another question, say it says t into t plus 3, and then you're told to expand. What do you get? You say t times t, you get t squared. T times 3, you get 3t. Correct. And what about if you're given k into k minus 3? What do? You say k times k, you get k squared, and minus 3 times k, you get minus 3k. Correct. So you see, all of this is from smaller to big. And then you have 2k plus 3m. Expand. You say 5 times 2, you get 10k. 5 times 3, you get 15m. And you leave it in that manner. What if you have 4g into 2g plus 5? So 4g times 2g, you get 8g squared, plus 4g times 5, you get 20g. Correct. Then what if you have this? You have another one, like for example, it says Dylan wrote the following. So you've been given a question, say Dylan wrote the following. So you have 3 into 5x minus 4, and then is equal to 8x minus 4. Dylan has made 2 mistakes. Explain the mistake that Dylan has made. So Dylan has made 2 mistakes. Explain the 2 mistakes that Dylan has made. Okay, so they say the answer is 8x minus 4. So let's expand. 3 times 5 you get 15x. 3 times 4 is minus 12. So when you expand, you say Dylan, the first mistake that Dylan made, he added the first one, like 3 plus 5x, and he got 8x, and he never did anything towards negative 4. Because when expanding the bracket, you have to multiply everything with whatever is inside. So 3 times the first term and times the constant. So 3 times 5x, you get 15x. 3 times negative 4, you get negative 12. So here, what he did, just say 5x plus 3, you got 8x, and then put there, and then he didn't do anything on the second constant number. That's the mistake that Dylan did. Okay, so the rest is history. In the previous class, I taught you when you have w and then you're multiplying by 2w. Here, you have to remember, it's a must for you to remember, laws of indices. There is no shortcut towards that. Like you just need this w power 1 times 2w power 1. So 1w power 1 times 2w power 1. W power 1 times w power 1 is w power 2. 2 times 1 is 2. So 2w power 2. This is the shortcut. There is no other shortcut. You have w power 3 times w power 1. What you just need to do is just w. 3, because we are multiplying w with the same base, you just say 3 plus 1, you get 4. W power 4. You have, let's say you have 4h squared into 3h plus 2g. What you need to do here, just say 4 times 3, you get 12. H squared, so what you need to do here, you need to multiply coefficient by coefficient and then the letters by letters, or we can say expressions. So if 4 times 3 and then h squared times h. So you get 12, then h power 1 times h power 1. H power 2 times h power 1 is h power 3. Then plus 4 times 2 is 8. And then h squared g. You get your answer. This is the only shortcut. We don't have any other shortcut. Simplifying. So simplifying means you have to write your expression in the smallest unit possible. Simplifying in algebra means writing an algebraic expression in the smallest unit possible. And you can only do this. First of all, what you need to do, you need to collect like terms. So we have talked about like terms. We say like terms can be in form of squares and cube, like the coefficient with a let's say 2t and 1t or 7t. Those ones are called like terms. But you cannot say it's 2t and 7b. They are like terms. They will never be like terms. But they can have different, maybe one is positive, the other one is negative, but they have the same variable, provided that they have the same variable, but different coefficient. They are called like terms. One can be 7b and another one can be 5b. It's okay. One can be 6d and another one can be negative 3d. Provided that they have the same variable, dd, they are called like terms. But you cannot say 7t and maybe 3b. You say like terms. This one cannot be like terms. They cannot be like terms because they have different variable t and b. So I think with that, you are in good position to understand. Now, what happens when we are supposed to expand and factorize and sometimes simplify? So I think in the morning class, I taught you how to expand, and I will also try to do this one so that maybe I will give you like 2 or 3 examples. So example 1, 4 into 3 plus 2h, and then minus 2 into 5 plus 3h. Majority of these questions, they are always tested in core paper. You will see them in core paper. So 4 times 3, 12. 4 times 2h is 8h. Minus 2 times 5 is minus 10. Minus 2 times 3h is minus 6h. So if you do that, say 12 plus 8h minus 6h minus 10. So 12 minus 10 plus 8h minus 6h. You say 12 minus 10 is 2 plus 8h minus 6h is 2h. Correct. This becomes your answer. We have expanded and simplified. You might have this one. You have m into 4 plus p plus p into 3 plus m. Correct. Now let's expand. You say 4m, m times 4 is 4m, m times p is mp plus 3p times pm. Correct. Or mp. And then you say collect like terms. So it's 4m plus mp, which plus mp, which is the same as mp, plus 3p. What do you get? You say 4m, 1 mp plus 1 mp, you get 2 mp plus 3p. This becomes your answer. Correct. Another question that you might have is you have expand and simplify each expression. You have t into 3t plus 4, then plus 3t into 3 plus 2t. So what do you do in this case? T times 3t, you get 3t squared plus 4t. 3t times 3t, you get 9t squared plus 3t times 2t, you get 6t squared. Correct. So 3t squared plus 9t squared. 3t squared plus 9t squared plus 6t squared plus 4t. They are all like terms. 3t plus 9, 3 plus 9 is 12. 12 plus 6 is 18. So you get 18t squared plus 4t. Correct. This becomes your answer. Amazing. Amazing. So you'll have majority of these kind of questions and they'll be like that. Now, what happens when you expand to algebraic expression? Wow, that's good. What happens when you expand to algebraic expression? This is what happened. You have an algebraic expression, let's say, a plus b. Then you need to expand with a plus b. For instance, let's say you need to find the area. Find the area of a square whose length is a plus b centimeter. Now you can draw a square. You scale property of a square. All the sides are equal. Then you have a plus b. Then a plus b centimeter. The area obviously is length squared, which is length times length or side square. So you have a plus b, expand by a plus b. Now, when you expand this, obviously, a times a, what do you get? You get a squared. A times 1 times a times 1 is a squared. Plus a times ab, the same. You get ab. Then plus b times a, you get ab. Then b times b, you get b squared. When you add this, you get a squared plus 2ab plus b squared. When you expand two algebraic expressions, the resultant is quadratic. The resultant is quadratic expression in the form of y is equal to ax squared plus bx plus c, where a, b, and c are coefficients. Correct. That's the most important. So let's go. Let's check. You have, let's say we have x plus 4. Expand this. This is the same as you have x plus 4 times x plus 4. When you multiply this, x times x, you get x squared, and x times 4, you get 4x. Then 4 times x is plus 4x, then 4 times 4 is plus 16. So you end up x squared plus 8x plus 16. This is what you end up getting. Correct. This is fine. So majority of the questions that we will do in this unit, expanding, now you'll be able to understand what will bring out when you expand two algebraic expression. Now, what happens if you have different? That's something that we will do in our next math class. So stay connected. In the next math class, we will be reviewing now something called quadratic expressions, quadratic equations, and how to expand and factorize them. Wow, how to expand. We'll start by how to expand quadratic expression, then later on how to factorize quadratic equation, and maybe how to solve them. So the unit of quadratics will have started like that. Thank you. See you at the top champion. Bye bye until we meet again in my next class.